Title your notes, segment, addition, and midpoint. So I want you to take a look at this number line. I plotted some different points for you. There's all different segment combinations available, and I just want you to find two segments that have the same midpoint. Let's see. So here's a suggestion that we are given, BC and CD. Do y'all remember how to find a midpoint? It's only been a couple of days, right? So to find a midpoint, like to find the midpoint of BC, you add the coordinates and divide by 2. So if I add the coordinates and divide by 2, his midpoint is -1. CD. Uh-oh, I have a feeling this is not going to be the same midpoint. 3 plus 11 divided by 2. His midpoint is 7. So unfortunately, those two do not have the same midpoint. So do you see what the question was asking now? That suggestion was a good start. Why was that suggestion presented, though? Even though those midpoints aren't even close, one of them is -1, and one of them is 7, why was that suggestion presented? What do BC and CD have in common? So, the length of BC is 8, right? And the length of CD is 8. But when you do 8 divided by 2 and you get 4, is 4 the midpoint? You have to be careful. Yeah, 4 is how long the distance is from the end point to the midpoint. 4 is a length. It's not a coordinate. Okay. All right, let's look at AF. What is the midpoint of AF? So you add them up and divide by 2, and what do you get? C is the midpoint of AF. And then BD, from here to here, add them up and divide by 2, and what do you get? Ah, beautiful. So two segments that have the same midpoint are AF and BD. Okay, good. That was just kind of a starter to our lesson, getting you started. Put this down in your notes. I want to remind you about notation. When we use an equal sign, we're talking about measures. We're talking about length. We're talking about numbers. So when we use an equal sign, those are distances, measures, lengths, numbers. When we use a congruent sign, that's when we're talking about objects, about segments. We're not talking about their length. We're not talking about numerical value. We're talking about the object itself, like a triangle or a segment or a circle, that kind of thing. So just wanted to remind you the difference in notation. Just to make sure you understand, don't put this in your notes, but decide which one of those is written incorrectly. All right, let's talk about them. AB equals 12. The distance from A to B is 12. That is good. That is correct notation. Let's look at C. Hi, yo. Segment hi is congruent to segment yo. Those are objects. Objects are allowed to be congruent. Check. Now it's between B and D. The length of MN is congruent to the length of OP. And so numbers can't be congruent. So this is the one that's written incorrectly. And this is actually what we're learning today. So that last one is written correctly, and it is part of our lesson today. Alrighty, in your notes, I would love for you to draw a figure. 3 points A, B, and C are collinear, and B is between A and C. How many, oh, that's cute. How many of you, when you drew your figure, how many of you put B right smack in the middle? Okay, so what I want to be clear of is what this word between means. We're talking about betweenness and what that means. So B, the fact that it's between A and C. Ooh, I wonder if it'll let me do this. No, it won't. I should have put my... Between does not mean right smack in the middle. And I think a lot of us, that's our instinct, is to put it in the middle. But B could lie anywhere along this line. B could be here, 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 here. Okay? So we did not have to put B in the middle. Between kind of means along the line. It doesn't necessarily mean in the middle. It doesn't mean midpoint. Between is not a synonym for midpoint. Okay? Another thing I want to point out is I know it said they had to be collinear. But I want to talk about this picture real quick. In this picture is B between points A and C. Whoa, I got frozen on a really weird screen right there. Okay, all right, is it between? So in geometry, betweenness means something. For a point to be between two other points, they actually have to be collinear. So I realize that if you did this, I realize that B is between those two lines. But B is not between points A and point C. So this picture is not between. This picture is between. So I just want to make sure we understand that. All right, the next thing to put in your notes is what's called the segment addition postulate. Write it down and we'll fill in the blanks. Segment addition. Do y'all know what goes in those blanks? If 3 points A, B, and C are collinear, so just to let you know, this is kind of like a conditional statement, an if and a then. This does not work if they're not collinear. They have to be collinear. That's an important building block of the segment addition postulate. If they're collinear and if B is between A and C, then AB plus what? Do you know? BC equals, that is like groundbreaking news, right? Okay.
I totally got it.
That's called segment addition. So segment AB, the distance from A to B, plus the distance from B to C, equals the distance from A to C. Another way to put that in layman's terms, I'll say this a lot, is part plus part equals whole. So when you hear me say part plus part equals whole, I'm really just summarizing the segment addition postulate. Okay. Did I put segment symbols above those? No, because those are distances. They are not segments. Okay. Now, putting your notes midpoint, this is the other half of the lesson, is going over what a midpoint is, and I'm not talking midpoint formula. I'm not talking midpoint on a coordinate plane necessarily. We're talking midpoint in reference to segments now, okay? So what goes in those blanks? A midpoint is a point that blanks a segment into two blank segments. What goes there? Point that, I think y'all are piecing it together. It's a point that divides or splits would work too, divides a segment into two. I'm not going to use equal, I'm going to use congruent because we're talking about objects, we're talking about segments, we're not talking about lengths yet. A point that divides a segment into two congruent segments. So if my statement said point B is the midpoint of segment AC, then I know B divides that segment into two congruent segments. I know AB is congruent to BC. Cool. Okay. Take a look at this side. If B is the midpoint of AC, compare the following values using equal signs and or numerical operators. Is that kind of confusing? So here's my example. And this is not the correct answer. See how I filled in, it was like G, H, and then HJ. And to make this a true statement, I put equals and I put a 5. So fill in the space between those two segments using equal signs and numbers to make them true. I'll give you a minute to try that. All right, so the first one is asking you to compare the length of AB to the length of AC. So could I put this? Could I put that? A AB equals 2AC. And good, yeah. I don't want to put that. Could I put that? AB is 1/2 of AC. That would work, right? What about the next one? CB. How does it compare to AB? Well, that one's easy. What do you put? An equal sign, right? Equal. Yeah, and then the last one. CA, the blue, compared to BC. CA is what? Double BC. Yeah. So we used equals 1/2, we used equals, and then we equaled times 2, excuse me. Okay, on this slide, I do not want you to write this down. I just want to talk strategy. We're not going to solve anything. We're just strategizing. Is that a word? Okay. What is a strategy? So, how would you solve for x on this problem? I see it. Okay, Alex, I see it. Trick question. On this one, you wouldn't solve for x at all because you do not have enough information. Did everyone hear me? On this one, you do not have enough information. I'm going to add this information to my picture. Now, how would you solve for x? So we're blending algebra with segment addition. Is that okay? You would set it equal. 3x equals 27 because segment GE equals segment EO. Okay. So that's like setting the half equal to the half. All right, let's look at the next one. I don't care about what x is. I just care about the setup for right now. Look at the next one. What would you do here? A lot of times I have students that say 3x equals 54. And they know that isn't true. They know a half doesn't equal a whole, but they just don't know how to start it. So yes, you have two choices. When you are given a half versus a whole, you can either double the half or what's the opposite of doubling a half? What could you do to the whole? Oh, you said it. You could half the whole. Yep. Or you don't have to do both. Or 3x equals, it doesn't equal 54, it equals 27, right? So you either double the half or you half the whole. That's what you do when you're given a half and a whole. Let's do this last one. What about this one? Notice the tick marks are not there anymore. Gone. I don't see any tick marks. So this is a midpoint problem. This is a midpoint problem. This is not a midpoint problem. How do we solve this one? It's called segment addition. Right? So this one would be part plus part equals whole. So do you see what's going on here? These are the three different segments that you could encounter. All right, we're going to try about 3 or 4 examples. DE equals 3x. EF equals x minus 6. And DF is 30. Find x. Is this a midpoint problem or a segment addition problem? Kind of a clue is when you're given 3 things instead of only given 2 things, it's a segment addition problem, not a midpoint problem. All right, so we're going to do part plus part equals whole. And then you're going to work your algebra. You love that algebra. You're going to do it. Yay, algebra! Woo! Part plus part equals whole. Let's try another one. M is the midpoint of AD. Stop right there. Stop in your tracks. When you see that word midpoint, you add tick marks to the picture. Boom, add tick marks. Solve for X. I notice I'm given a half and I'm given a whole. We are not going to rush into this problem and set them equal. Remember, you have two choices. You can double the half or half the whole. So, you can either take 28 and divide it by 2 and say, oh, these are both 14 and 14. So 2x minus 9 is 14. Or you could double the 2x minus 9. We're going to do it this way because I like working with smaller numbers if I have a choice rather than bigger numbers, larger numbers. 2x equals, what do you get? All right, never mind. Okay, so we divide by 2. $11.5. Do you know how you could check your answer? Do you know how you could check your answer? You could substitute it in. You could plug it in. 2 times 11.5 minus 9. And you get 14. If AM is congruent to MB, then this one's 14 as well. And 14 plus 14 equals 28. Next problem. M is the midpoint of AD, so you stop right there and you add tick marks. AM is 4x. AB is 2x plus 12. Solve for AB. Here's what you don't do. You don't write AB equals 2x plus 12. Believe it or not, I've had students do that before. So we don't want to do that. I'm looking for a numerical value here, so be careful. This is a half and whole problem again. I gave you 2 in a row because my students usually struggle with it. I am not going to set those equal. I am not going to set those equal. I can double the half. I can say 2 times 4x equals my whole. So 2 times the half equals the whole. I could do that. Or I could take the whole and divide it by 2. It's up to you. 8x equals 2x plus 12. 6x equals 12. X equals 2. Now be careful. It was not asking for, my camera's frozen. It was not asking for x. You do need to plug it in. 2 times 2 plus 12. 4 plus 12. So the length of AB is 16. AB is 16. Okay, we're going to do this as the last problem today, even though my camera is completely frozen. R is between B and O. I always like to take my words in my math problem and turn it into a picture. What I'm not going to do is trick myself and put R as a midpoint. We were not told it was a midpoint, so I'm going to make sure I don't put it in the middle and trick my mind, okay? R is between B and O. RO is 1/3 of BR, and BO is 40. Okay, let me teach you the quickest way to put that statement into your picture. RO is 1/3 of BR. So what I'm going to do, and my picture's not drawn to scale, by the way, what I'm going to do is RO is 1/3 of BR. You see how I did that? I put a 1 and a 3. It is, so the equals means is, 1/3. So RO gets 1 of the parts, and BR gets 3 of the parts. I want you to think of those as, I'm going to attach an X to them, because I want you to think of those as like a proportion, as a ratio, as a part. RO is 1/3 of BR. So if I really wanted my picture to be drawn to scale, the R would be closer to here. No big deal. Anyway, now that I've labeled my picture, I can do segment addition. Part plus part equals whole. 1x plus 3x equals 40. 4x equals 40. X equals 10. And now I can plug it back into my parts. RO is 1 times 10. BR is 3 times 10. Now I could check my work. Is RO 1/3 of BR? Is 10 1/3 of 30? Well, yes, it is. Is 30 plus 10 equal to 40? I'm checking my answer. Yep. So this works and this works. So we did it correctly. Now, what I want to tell you, a lot of students do wrong. Here's what they do wrong. They see the 1/3 and they see the 40 and they just divide it by 3, or they multiply the 40 times 1/3. But there are not 3 parts here. There are 4 parts, because RO is 1 of the parts and BR is 3 of the parts, and 1 plus 3 is 4. There'll be some more examples on tomorrow night's homework that look like that. Okay, I want to leave you with this exit ticket, and then you can work on your homework. Determine the validity of the statement. If B is between A and C, then A, B, and C are collinear. True or false? We talked about this a little bit. Good, good. It is true. It is true because we talked about what between really means. To be between, they would have to be collinear. It's a prerequisite. What about the converse? If A, B, and C are collinear, then B is between A and C. What do you think about that? Good. Good. False. So that sentence is true, but the converse is false. Because I can make them collinear, but I could put B here and A here and C here. That is my counter example. All right.